Hi students. Today actually it is the continuation of hybridization. In the last previous videos we have discussed about the types of hybridization and what is hybridization and what are the geometries, how to find out the hybridization, all these things we have discussed. Now here I would like to discuss about the shapes. So here I told you geometry is different from shape. Now in this video we will discuss how to predict the shape of a molecule or the ion. Okay, now if it is the first time you are watching my video, please watch all the previous videos regarding hybridization, then this will be more clear to you. And if you want me to discuss about any particular topic or unit, you just comment me or ping me in the comment section, so that I'll definitely come up with that video. Okay, now let's get into the topic, that is how to find out the shape of the molecules. So here, before entering into this topic, what is the geometry? Here I have already discussed how to find out the number of bond pair of electrons and number of lone pair of electrons. So here geometry will predict geometry of any molecule. It is based on bond pairs plus lone pair. So here in the geometry, while predicting the geometry, will include both bond pairs and lone pairs. But if you want to predict the shape of any molecule or the ion, that is only based on the bond pair of electrons. Okay, just keep this point in mind. Now I'll tell you how to find out how to predict the shape of any molecule. Okay, here geometry is nothing but bond pair of electrons and bond pair of electrons and lone pair of electrons, but the shape is only based on the bond pair of electrons. Okay, clear? Now you just make it as a tabular form. So first one bond pairs, second one lone pairs, and third one bond pairs plus lone pairs. Okay, so make another note. Here I told you geometry means it is bond pair plus lone pairs, and shape means only you have to consider bond pair of electrons. Now if this is the first note, and second note, if lone pair of electrons is equal to 0, then geometry will be equal to shape. Whatever the geometry is there, for example you take CH4 molecule, here lone pair is 0. So here geometry of CH4 is tetrahedral and the shape of the CH4 is also tetrahedral. So first you make this note, if lone pair of electrons is 0, then geometry is equal to shape. Keep these 2 points in your mind. And now first one bond pair of electrons, lone pair of electrons, bond pair plus lone pairs, and the next geometry, and next column it is shape. Okay, now how? First one, here if 2 bond pair of electrons is there, if 2 bond pair of electrons are there, number of lone pairs 0, bond pair plus lone pairs, here it is equal to 2. Now what will be the geometry and what will be the shape? And you make another column here between this geometry. Actually it is hybridization. What is hybridization? Okay, so between these two you make another column. Between these two you write another column, that is hybridization. So here if it is 2, what is the hybridization? It is sp hybridization, one s orbital plus one p orbital. So altogether it is sp hybridization. Now here what is the geometry? So I told you, no, if here hybridization is, if it is an sp hybridization, so here it is geometry is linear geometry. Here it is the central atom. You write this as a central atom C and two atoms like this, and with a bond angle of 180 degrees. Lone pair of electrons is equal to 0. Here shape is also, here what is the geometry? Here it is a linear geometry, and here shape also linear shape. Okay, and examples for this one, BeCl2, MgCl2, all these are the examples for this one. Okay, now if you are given with the examples for this one, if you are given with BeCl2, how to find out the shape here? So here first BeCl2, central atom beryllium, it is the second group element, 1, 2 cross marks, and 2 chlorine atoms. Here 2 chlorine atoms, you attach each one chlorine atom to one cross mark and another chlorine atom to another cross mark. So here what is the hybridization altogether? Here how many bond pair of electrons? Here 2 bond pair of electrons. Lone pair of electrons is equal to 0. So here 2 bond pairs means it makes sp hybridization. sp hybridization with a geometry of this one, with a linear geometry and a bond angle of 180 degrees, and here lone pair of electrons is equal to 0. Here the shape is also a linear in shape. So if you find, similarly you find out hybridization for this one also, MgCl2. Okay, clear? This is the first one. Bond pair of electrons, here I have taken 2 bond pair of electrons, so 0 bond pair plus lone pairs, and what is the hybridization, geometry and shape, examples. Okay, clear? Next one, second one. Here if it is one bond pair, just assume one bond pair and one lone pair. So here with one bond pair and one lone pair, any molecule species will not adopt such structure. So here there is no structure exists with one bond pair and one lone pair. Okay, next you can write that also. And here next one, 3 bond pairs, 0 lone pairs, and here bond pair plus lone pairs 3. So what is hybridization? 3 means it is sp2 hybridization. If it is sp2 hybridization, what is the geometry? Here it is trigonal planar geometry. Trigonal planar geometry. So here that will be like this. Here central atom, here central atom. You take examples for this one, BF3, BH3, AlCl3, all these are examples for this one. Here the species with 3 bond pairs and 0 lone pairs. So here directly I am writing central atom B, F, F, F. So how to find out the hybridization? Boron belongs to third group. So 3 cross marks. BF3, 3 fluorine atoms, 1, 2, monovalent atom, no, fluorine and all the monovalent atom you attach with 1 cross mark. So here bivalent atom like oxygen, 2 cross marks, we attach 2 cross marks with 1 oxygen. So here here if you are first time watching my video, please do watch all those videos regarding hybridization, then only this will be clear to you. Okay, here 1, 2, 3, how many bond pairs? 3 bond pairs. So lone pairs, 0 lone pairs. So 3 bond pairs means it is sp2 hybridization. So what is the geometry? It is trigonal planar geometry with a bond angle of 120 degrees. With a bond angle of 120 degrees. Now I told you these are the examples for this type. So here as lone pair of electrons is equal to 0. So here geometry is equal to shape. Now what is the shape for this one? Here it is also a trigonal planar shape. What is the shape? It is trigonal planar. Till now we have not included lone pairs. So next here I told you if lone pair of electrons is equal to 0, then geometry is equal to shape. So if you are asked with what is the shape of BF3 or BH3, anyone you can try by finding out by adopting this method and finding out hybridization, and then after finding out the hybridization, bond pair and lone pair of electrons, easily you can predict the geometry or the structure. And based on the structure means geometry or the shape, based on that shape you can predict the bond angle also. Okay, so here it is a trigonal planar in shape, and the geometry it is also trigonal planar geometry. This is like that. Okay. Now, the next one, I'll clear this one. Now I'll clear this one. It is central atom BF3 with a bond angle of 120 degrees. Okay. Now here in the second column we have considered 3 bond pairs. Now among these three split it as 2 plus 1, 2 bond pairs and 1 lone pair. So here bond pair plus lone pairs 3, and what is the hybridization? As it is 3, and the hybridization is simply sp2 hybridization only. But what is now what is the geometry? Here the geometry means here bond pairs plus lone pairs. So bond pair plus lone pairs 3, and hybridization is sp2, and the geometry will be trigonal planar only. Are you getting my point? So here there should not be any doubt regarding this. Here 2 plus 1 3, bond pair plus lone pairs 3, and hybridization sp2. Here if we are predicting the geometry, it is bond pairs plus lone pairs 3. So the geometry, hybridization is sp2 and the geometry is trigonal planar geometry only. Now here, while predicting the shape, where to keep this lone pair? Because here while predicting the shape, we will not include lone pairs. So if at all one lone pair is there, how to write the structure? So here, C means a central atom. So actually this is the geometry. These are the surrounding atoms. Okay. Now, one lone pair is there. You keep that lone pair here above this. And now, you should not consider the lone pair. So here, if you assume it as this, what I have written, it is in the plane of paper. You just assume the lone pair is present on the top of the central atom. So what is the structure remaining? This is like this. Got my point? Here you should not consider this because lone pairs are not included while predicting the shape. Now what is the shape here? It is angular in shape. Angular. Okay? Angular. Now here I want to tell you here lone pair and bond pair we are telling. Lone pair of electrons means a lone pair of electrons only, and bond pair means here these are the electrons present in the bond, those we call as bond pair of electrons, and here there exists a repulsion between the electrons, isn't it? So here the more repulsion, more will be the distortion in the structure, because if repulsion increases, energy also increases, so the molecule undergoes some distortion in its geometry. So here lone pairs disturbs the geometry. Because of the lone pair, the geometry will be disturbed. Means here we will get the distorted geometry. Means because of the lone pair, here the trigonal planar geometry is distorted to angular. So whatever here, the repulsions order will be lone pair repulsions are greater than lone pair repulsions, which are greater than bond pair. Because here in the bond pair also, in the bond also, here 2 electrons will be there. There exist repulsions between the bond pair of electrons also. So here what is the order you should remember? Please make it as a note. What are the repulsions here? Lone pair. The repulsions between the lone pair and lone pair of electrons is larger when compared to lone pair and bond pair. Means lone pair and bond pair. Okay, this lone pair of electrons, this lone pair means 2 electrons. So here there exists a repulsion between these two, lone pair, bond pair repulsion. If another lone pair is there, there exists a repulsion between the lone pairs and lone pairs. So lone pair repulsions are greater than lone pair, bond pair repulsions. And also here bond pair also electrons only, no? So there will be a repulsion. So bond pair repulsions. So please make it this as an note. Make it as a note. Now we'll get into the topic. So what is the shape now? Here the shape of this one is angular in shape with the bond angle. So here the bond angle is 120 degrees. Because of the repulsions, the bond angle will be decreased to less than 120. Less than 120. And here example for this one, you can write PbCl2. So here this belongs to 4th group. 1, 2, 3, 4. 2 chlorine atom. So 2 bond pairs plus 1 lone pair. So here this angular, or in some textbooks it will be given as a bent shape also. You can call it as a bent shape. Here this will be like this, and you assume this as a lone pair. Okay, trigonal planar lone pair. So here lone pair you will not include while predicting the shape. So got the difference? What is the got the difference between geometry and the shape? Here geometry means bond pair plus lone pair, and the shape means it is bond pair of electrons only. So here this is the example for this one. So here if one lone pair, here if two lone pairs are there, two lone pairs and if 2 lone pairs and 1 bond pair, here repulsions will be very high. So this 2 lone pair, where these 2 lone pair occupy? So here any molecule will not adopt such structure. Okay. So here it is, if it is altogether 2 plus 1, 3 bond pair plus lone pair, hybridization is sp2, and the example I have given is PbCl2. If you are given with PbCl2, hybridization sp2 hybridization, 2 bond pairs and 1 lone pair. And here it is, the geometry is trigonal planar geometry, but coming to the shape, it is angular or bent shape with a bond angle less than 120. Okay, clear? Next. If 4 bond pairs are there, 4 bond pairs are there. So here lone pairs 0. So bond pairs plus lone pairs 4. What is the hybridization? sp3. sp3 hybridization. I'll clear this one. sp3 hybridization with a geometry. What is the geometry if it is sp3 hybridization? 4 means I told you, no? It is tetrahedral geometry. It is tetrahedral geometry. Central atom, this will be like this. Central atom, and these are the surrounding atoms with a bond angle of 109 degrees 28 minutes. Okay. Now here lone pairs are 0. Geometry is equal to shape. Lone pairs are 0. Geometry is equal to shape. What is the best example for this one? It is CH4. It is CH4. Now you take CH4, write the hybridization, how many bond pairs, how many lone pairs, and what is the shape, and what is the geometry, and what is the bond angle. Okay, CH4, CCl4, BH4 minus, you can write these examples. Okay, BH4 means here boron belongs to third group, minus 1. Here anion is there, 3 plus 1, 4. So 4 cross marks and hydrogens. BH4 minus. So 4 bond pair of electrons. So 4 bond pair of electrons means what is the hybridization? sp3 with 0 lone pairs if it is sp3, and the geometry is tetrahedral. Okay, now you can write CH4, CCl4, BH4 minus, and BF4 minus, AlCl3 minus, AlCl4 minus actually. Yeah, all these are examples for this one, fourth one. Okay, clear till now? So here lone pair of electrons is 0. You can write these examples so that you can practice. CH4, CCl4, BH4 minus, BF4 minus. BF4 boron belongs to third group. 3 plus 1 because of the anion. 4 fluorine atoms. Aluminium also belongs to third group. 3 plus 1, 4. So 4 bond pairs. Clear. Okay. All these are examples. Okay. Now fifth one. Here you maintain the table as it is the continuation. So here we have taken the fourth one, 4 bond pairs, no? So here number of bond pairs, it is 3 bond pairs. I'll write again. Bond pairs, lone pairs, bond pair plus lone pairs, and the next hybrid. Okay. So here 3 bond pairs. If it is 5, fifth one. If it is 3 bond pairs, 1 lone pair, bond pair plus lone pairs, 4. Hybridization, it is 4, sp3 hybridization, 1 plus 3, 4. And what is the geometry? Here the geometry will be tetrahedral only. Geometry will be tetrahedral because geometry means here bond pairs plus lone pairs. sp3 hybridization means tetrahedral geometry. Then what will be the shape? Here because of the lone pair there will be a distortion in the shape, no? So first write the shape, first write the geometry, tetrahedral geometry. It is the central atom. Okay. Okay. Now it is the central atom and the surrounding atoms. Now if one lone pair is there, you just, I told you, you just assume this as, here, this is one atom means here, this is this one, and this is this my forefinger, and this one. Okay, and always lone pair will be placed, means here molecule adopt the structure in such a way that there will be minimum repulsions. So where to keep lone pair? If lone pair is present here, then only this molecule is comfortable. Or actually all these are experimental analysis. After performing an experiment, we will predict maybe this may be the reason. It is an hypothetical assumptions. So here the where is the lone pair? This lone pair will be at this position only for this one. If one lone pair is there, that will be placed on the top of the central atom. So here now you while predicting the shape, you should not consider this one because lone pair is there. Okay. Now here what is the shape now? Geometry is tetrahedral geometry, but what is the shape now? It is like a pyramid, you know. Pyramid. Just look this one. Look at this one. Pyramid. So now the shape is pyramidal. What are the examples? NH3, PH3. All these are examples for 3 bond pairs and 1 lone pair with sp3. Hybridization is sp3. Geometry is tetrahedral, but the shape is pyramidal. And here now the bond angle will be decreased. Means here from the 120 degrees the bond angle will be there. In the previous case also the bond angle, if one lone pair is there, the bond angle will be less than 120 degrees. No, I told you. So here tetrahedral means the the bond angle is 109 degrees. Now here less than 109 degrees bond angle means that will be approximately 107 degrees. You remember, for some molecules at least you remember what are the bond angles. Okay, so here if it is a tetrahedral geometry, 109 degrees 28 minutes, and if one lone pair is there, that lone pair will be placed on above this one, above the central atom. So here this will be the pyramidal in shape. Here this is one atom, this is okay, this is another atom. Here this atom, it is the plane of paper representation, but the view will be exactly like this, pyramidal in shape. Pyramidal in shape. Okay, clear? Now the bond angle is 107 degrees. So these are the examples for this one. So first you calculate, you take NH3. So NH3 means a nitrogen, central atom is nitrogen, belongs to fifth group, 1, 2, 3, 4, 5, fifth group 5 cross marks, and 1 hydrogen for each cross mark. How many bond pairs? 3 bond pair of electrons and 1 lone pair of electron. So 3 bond pairs plus 1 lone pair, 3 plus 1, 4. 3 plus 1, 4, hybridization sp3, tetrahedral geometry. Because of the lone pair, the geometry, here there is a distortion in the geometry from tetrahedral to pyramidal. So distortion in the bond angle, decrease in the bond angle. Why there is a decrease in the bond angle? Here because of the repulsions between the lone pairs and the bond pairs. Okay. So here the bond angle will be decreased from the bond angle will be less than 109 degrees, and here it will be approximately 107 degrees for ammonia molecule. Okay, so ammonia will write like this now. Lone pairs, 2 lone pairs and H3. It is pyramidal in shape. Clear? Super clear. There should not be any doubt regarding this. Okay? Okay. Next we'll move into the next one. Sixth one. Now next one. 3 bond pairs, no? 2 bond pairs, 2 lone pairs. You take 2 bond pairs and 2 lone pairs, and altogether 4. And what is the hybridization? sp3. And what is the geometry? Tetrahedral only. Okay. Now because here in the first case, in the fourth case, you look at the fourth case, 4 bond pairs with 0 lone pairs, tetrahedral geometry. From the 4, we have taken this one, 3 bond pairs, 1 lone pairs, same tetrahedral geometry, but the shape is the shape is pyramidal, and the bond angle decreased from 109 to 107. Next here, we have added another lone pair, 2 plus 2, 4, sp3 hybridization, geometry is same tetrahedral. Now where to keep this another lone pair? Here in the previous case only 1 lone pair is there, no? So above this central atom we have placed like this. Yeah, actually it is our actual representation, 3D representation, like this, not exactly, you just assume. Okay. Here we have placed 1 lone pair here, and here there is another lone pair. Okay, now you place this lone pair will be exactly like this. Okay, this. Now while predicting the shape, you should not consider the lone pairs. Now what is the shape here for this one? The shape is angular or bent shape. And here the bond angle is still less than 107 degrees. If 1 lone pair is there, the bond angle is less than 109, that is 107. And examples for this one is H2O and ICl2 plus, here I'll write this one, here H2O, ICl2 plus. For H2O, you calculate the hybridization. Oxygen belongs to sixth group, 1, 2, 3, 4, 5, 6, 1 hydrogen, second hydrogen, 2 bond pairs, 1, 2. 2 make 1 lone pair. So 2 lone pairs. 2 bond pairs, 2 lone pairs, 2 bond pairs, 2 lone pairs. Altogether bond pair plus lone pairs 4. Hybridization sp3. Because of the 2 lone pairs, the 2 lone pairs geometry is tetrahedral, but the shape is angular or bent. Now what is the bond angle? It is less than 107 degrees. Okay, you just compare. The geometry is same tetrahedral. If one lone pair is there, 107 degrees. If two lone pair is there, two lone pairs are there, that will be approximately 105, or in some textbooks it will be given as 104 also. Okay, so here H2O and ICl2 plus, you calculate the hybridization for that one. Iodine belongs to 7th group, plus means here group number -1, 7 minus 1, 6 cross marks, 1, 2, 3, 4, 5, 6, and here 2 chlorines, monovalent atoms, so 2 bond pairs, and 2 cross marks make 1 lone pair. It is 1 lone pair, 1 lone pair. So here altogether 2 bond pairs plus 2 lone pairs, 4 sp3 hybridization. Because of, but you have to analyze while predicting the hybridization. So here by practice you will get everything. So here what is the total bond pair of here? If you start from this one, here for example you just assume you are given with H2O in your exam. So what you have to do? First you have to find out what is the central atom is. Okay, oxygen is the central atom. Clear? Because from the beginning also I am telling you, hydrogen and fluorine cannot be a central atom because of their small size. So here oxygen will be definitely a central atom. Now what is the group number of the oxygen? It belongs to 6th group. So 1, 2, 3, 4, 5, 6 cross marks, and 2 hydrogens, attach 2 hydrogens. So 2 bond pairs. 2 cross marks make 1 lone pair, 2 lone pairs. So here 2 bond pairs plus 2 lone pairs, altogether 4. 4 means sp3 hybridization. This should be your thinking. Okay, 2 plus 2, 4, sp3 hybridization. sp3 means 4. The geometry that should come in your mind. Geometry, it is tetrahedral geometry. Now 2 lone pairs are there. Where to keep these 2 lone pairs? Here tetrahedral means you just imagine like this. 1 lone pair here above the central atom, 1 lone pair below the central atom, and you are left with, while predicting the shape, you should not include these lone pairs, and because of the lone pairs there will be a distortion in the geometry and the bond angle also. So here you are not including the above lone pair and below lone pair. What is the shape? It is angular or bent shape. Okay, and here if 1 lone pair is there, example ammonia 107 degrees, because it should be less than 109 degrees, because from our basic geometry 4 bond pairs geometry tetrahedral 109 to there will be a slight decrease because of the lone pairs. So here from 109, if you take CH4 as an example 109, NH3 as an example 107, H2O as an example 105 or 104. Okay, so here because of this should be like your thinking should be like this. Okay, then only you will definitely get the correct answer. Okay, and next here I think this will be clear. Now we left with another one, 7th one. I'll clear this one. Now if 3 bond pairs, 1 lone pair, altogether 4, and hybridization is sp3. Now geometry is tetrahedral geometry. Geometry is tetrahedral geometry. What is the shape and where to keep the lone pair? 3 lone pairs means here, and here this will be like we say it is a linear geometry. Linear geometry, because we will not consider, sorry, linear shape, not geometry. Geometry is tetrahedral, linear in shape, and here the examples for this one is CLF, BRF. So you find out for CLF, interhalogen compounds. We call them as interhalogen compounds. CLF means here, CLF, here fluorine cannot be a central atom. So chlorine 1, 2, 3, 4, 5, 6, 7 both belongs to same group. So 1 fluorine. So 1, 2, 3. 1 bond pair plus 3 lone pairs, altogether 4. 3 bond pairs, 1 lone pair, altogether 4. sp3 hybridization, 3 lone pairs. So there will be a distortion in the geometry and the shape is linear. The shape is linear. Okay. Clear? Okay. Next one. Okay. Remaining we will discuss in the next video. Okay. Till then, bye.